Had a question come in from a subscriber recently, a gentleman by the name of Philippe Anselme Vatin, and he'd been watching the video that I did on extension methods, and he was asking, is there a way that we can mock extension methods when we're doing unit testing, so that we can exclude the actual extension method and therefore focus on whatever bit of code it is we're testing? And actually, it's a little bit tricky to do, but there is a feature within Visual Studio called fake assemblies, which actually works very well with this. So that's what we're going to be looking at this week. Now, to begin with, let's just have a quick recap of the basic ideas of unit testing and mocking. So what we always start with is something that we'll call the class under test. So whatever it is, the thing we're trying to test it, make sure it does the right things. And we often abbreviate that just as the cut, because we really want to be clear in our minds what it is we're testing. We then have some test code, and the test code uses XUnit or whatever to call a method on the class under test. The class under test executes, returns a result, and then in the test code we simply verify that the result we got back matches the result we expected. And that will give us either a green light or a red light. But in practice, we very quickly come up with a slightly more complicated situation where, as well as the class under test, the class under test is dependent on something else that we'll just call some other class. And therefore, when the test is run, some code runs in the class under test, it calls a method in some other class returns a result, class under test returns the result. But if you get a red light, it's then not immediately obvious whether that's caused by an error in the class under test or in some other class, and therefore you've got to search a bit further to find where the bug is. Now, in simple cases, having to look in two classes rather than one class isn't going to be a huge problem, but obviously once the principle's established, this could be a huge long chain of other items, and we need a mechanism to isolate the class under test from other code. And the normal way to do that is to use a thing called a mock object pattern. Very simple idea. First thing we do is we apply the dependency inversion principle, which is to say, instead of the class under test being directly dependent on some other class, we introduce an interface that we'll call some other class because it exactly matches some other class. We then implement that interface in some other class, which should be very easy, and then from the class under test we reference the interface rather than the actual object. So that's broken the dependency. And what that then means is that although we're going to use some other class when we're actually running, we can, in our test code, write a mock some other class. And you can see there I'm putting it on the left because it's part of the test code, not part of the application code. But it still implements that same interface, and therefore the class under test can switch between the two implementations and will not be aware which one of them it's dealing with. But our mock some other class can, like all mock code, be very simple. It can just return a hard-coded value or essentially do nothing at all, and therefore there's nothing to go wrong, and therefore if we get a red light, we know it must be in our class under test. The problem with this, however, is that if the methods that we're dealing with in some other class are static, which is going to be the case with extension methods, which have to be static, but that means this problem also applies and the solution also applies with any kind of static method. If they're static, they can't be defined in an interface, and if you've got a static class, it can't be injected into the class under test using dependency injection or any other method like that. And in fact, this is one reason why we tend to try to avoid static methods if there is an alternative solution, because they are hard to test. But because extension methods are so widely used and are very useful in other ways, it's nice that we do have this mechanism that allows us to sort out this problem and actually do some mocking of our extension methods. So let's see how that actually works. And if we go into Visual Studio, what I've got here is actually, in terms of the extension method, exactly the simple one that I was using in that earlier video. So in here in extensions, I've got this extension method which extends the string class and is called toKebab. And what this does is it converts from Pascal case, which is what we normally use in C#, into kebab case, which is what we use in things like HTML and CSS and that sort of thing. So if we had something called my identifier name, in C# we would make that easy to read by simply having a capital M, a capital I and a capital N to make it legible. Whereas in kebab casing, it's all lowercase, and we insert dashes between the words to make it easier to read. So those are just the different styles we had. And all I had here with this to kebab was a way that it would take our input string and then make everything lowercase and put in those dashes. What I've done now though is I've put that into a program. So in this program here, we can see where I've created this thing called an element factory. And the basic idea is I want some kind of mechanism for automating the generation of elements, maybe in an HTML page or some kind of other XML. They're not genuine HTML elements we're dealing with here, but there might be something you used in Angular or some other library like that. So what I'm saying is I want to create an element of type hs/top with welcome as its content, and then another one of ps/main, another one of ps/sub. And here I'm just printing them out. But if we run that up, we can see that when I asked for my hs/top, hs was an abbreviation for header section, and then the top meant we got a class called indent top, and then we got the welcome as the content. Whereas ps was a page section, so we have those two page sections, and we have the class of level main or level sub, and then the content ones. So pretty trivial, but this sort of thing does feature in quite a lot of tools that are generating HTML or XML for you. Let's have a look at how that works. So if we just go into this create element, you can see that all that's really happening here is I've created a dictionary that matches those codes, PS and HS, just a couple of them so far, onto classes called page section and header section. And then what we do, we read that in, we split that, so that will split out the HS from the top or the PS from the main, whatever. And then based on that HS or PS, I look up and create my element. I then pass in that other bit of the parameter, so what came after the slash, so top or main or sub, and that just gets set up for the class. But then the key thing that's most important is here, I do element get type, get the name, so that is going to be either page section or header section as a string, but in Pascal casing, because this is C#, and then that's where I do my to kebab, and then I just put on the class, put it all back together, and that was where we got the results looking like that. The classes themselves are really pretty trivial. We've just got page section derived from this element base, similarly with the header section, so nothing really special in there. As well as having the program that just prints those out, I've also, because this is all about unit testing, introduced some unit tests. In fact, I'm just testing the one example. So here we've got a create page section. So it asks for ps/3 with hello world of the content. And as we can see, it's expecting the result there to be the page section with obviously the kebab case, class of level 3, and hello world. And if we run the unit tests, we can see we're getting a green light on that test for create page section. What I'm going to do now then is I'm going to deliberately introduce a bug into this software. And to maintain an air of mystery, I'm not going to tell you what that bug is, because let's face it, in a real programming situation, if your colleague accidentally puts a bug in the code, they don't ask you to have a look while they do it and show you what's happening. It's something you're not going to know about. So I will just make the slight changes here. It's not a very big change. But then when we run that up, the eagle-eyed of you may notice already what the bug is, but certainly if we run the tests are going to now give us a red light. And so we can see there we've got a red light, and if we look at the error message, it's telling us there was a mismatch between the expected and the actual, and you can see the exact point of it there. It's missed off the hyphen, and again we can see that there it's just page section rather than page dash section. So to some extent the unit testing has done its job. It has told us that there is an error, but it's not really focused us in very closely on where that error is. And because the error is missing off that dash, and putting in the dashes is part of the job of the to kebab, then we might think that that's where the error's occurring. But we can't be sure because we haven't done any isolation, and therefore we don't know which of the classes involved is going to have the error. So that's where we want to now do our mocking, and we want to mock the toKebab, the extension method, so that we know if now we get a green light, then the error must have been in the toKebab, whereas if we get a red light, when we've removed the toKebab, we know that the error must be in our other code. What we're going to do here is we're going to solve this problem using fake assemblies. Now, fake assemblies are something that's been around in .NET Framework for quite a while, but it's one of the features that was rather slow to be ported into .NET Core. And in fact, it still counts as a preview feature. So in order to get this to work, you've got to make sure you've got it enabled. So it may already be enabled, but the first thing to do, go into Tools, Options, and then down here under Preview Features, just make sure we've got it there, that Fakes for .NET Core and SDK style projects is checked. So make sure that's turned on. Then the next thing we need to do is in our test project, we open up dependencies and go into projects, and we find the assembly that contains the thing that we want to fake, the thing that we want to mock. And remember, in our case, that is the extension methods in the class that we've got there called extensions. So part of that element generator. So I click on the element generator reference in the test code, and then you can see there we've got add fakes assembly. So I'll click on that. And all that does, obviously, is just creates this folder called fakes, where we've got element generator.fakes, and in there, it's just basically got a specification of the name of the assembly for which we want to generate the fakes. You can actually put rather more detail in here. You can actually specify individual classes that you want to fake, but I'm just going to do it for all because it's rather simpler. But that will actually mean that when we build this, we now get our fake assemblies. So then what we do in our test code is this, because we can now say element generator, so that was our namespace in that assembly. It's now got a sub namespace that was generated as part of that process called fakes, and in there it's got this thing called shim extensions. Now you'll notice for the element factory, which was a non-static class, it's given us both what it calls a shim and a stub. And a stub is actually rather more like a traditional mock object, but a shim is the one that we need to use with static classes and static methods, and that's why we've only got the shim for our extensions class. So we get hold of that, and then we can see on there, as well as a few other bits and pieces, it's got properties specifically relating to our static methods, and so there is our static extension method toKebab string. That string has just been tacked onto the end of the method named toKebab because you can't overload properties, and therefore you've got to include the parameter name of the method into the property name. And then at this point, we want to define the mock behavior. And we do that with a lambda, so we're going to say equals, and then let's just remember, if we take a look at this method, it takes a string and it returns a string. So what we're going to do here is just use a lambda s gives, and remember this is mock code, so it should do the absolute bare minimum, and the bare minimum it can do here is nothing at all. So s gives s. So we'll pass in the Pascal case, do absolutely nothing with it, and then therefore return the Pascal case. And that will mean, obviously, that our results are now different. That should mean that here we get page section as Pascal case, not as kebab case. So that should tell us, if we still get a red light, that it wasn't an error in toKebab, that it was an error in the other code. One other thing we've got to do, because we haven't really defined the scope for which our toKebab should behave like that. So what we do is this. We will say using, and then we say shim's context, which you can see comes from the Microsoft library, so that's not something generated specifically for our library, that's what's always there. Then dot create. And we put that in the using block, which means that when we leave the using block, that will be destroyed, and so that is basically defining the scope over which this behavior should apply. So let us now run the tests. And if we run the tests with that shim in there, we can see we're still getting a red light. And so what that immediately tells us is because we've isolated our class under test from the 2kebab extension method, the 2kebab extension method was not the problem. And in fact, if we look at the detail, we can see what the problem actually was. We're expecting page section capital P, capital S, and we're getting page section with a lowercase s. And because we've got the lowercase s there, that's why further down the line the 2kebab failed, because it didn't know to put the dash in there. So it's actually a bug in some other part of the code, even though it looks like a bug in the 2kebab. And in fact, I can now show you what I did to break it. In our page section, I deliberately misspelled the name of the class to have a lowercase s in there, and that's why it wasn't working correctly. So if we change that back and just do a rename, now we should see when we run the tests that we're getting green lights there, and so it's correctly generated that. And when we run the program, we're back to getting page dash section. So what we've got there is really quite a neat way of dealing with situations where in our class under test we've got a dependency on a static method or a static property, and in this particular case an extension method, because they have to be static. Another example of where this is quite widely used is, if you remember, the date time class that has a static property called now to get the current date and time, and when you're doing unit testing that's absolutely horrible, because obviously the current date and time changes by the day, by the second, and so that's something else we'll often shim in this way so that we can control what is regarded as now in terms of unit testing. But I hope you found that helpful. If you're interested in more features of these fakes and shims and stubs, then do let me know, and I may do another video on that. But if you like that, do hit the like button, do subscribe, and I'll see you next time.